Patrick Higgins, and along with my coworker, Andre St. Germain, we are going to give a presentation called Complementary Railroading, How Planning, Design, and Construction Improve New England's Railroads. We're using the phrase complementary railroading because there are really three key aspects of any railroad project. There's the planning stage, which includes making sure the project's in the state rail plan, applying for grant funding, and I'm going to talk about some of the noteworthy grants that have happened in the region. And then there's the design phase, which we're going to provide two specific examples of some innovative bridge design techniques happening in Connecticut. And then there's that construction phase, which we're going to spend some time talking about both the Walk Bridge and the Connecticut River Bridge, two iconic railroad bridges that are going to have dramatic improvements on service in the region. When we think about planning, the first key element of planning involves the CT State Rail Plan. The CT State Rail Plan is going to be a state rail plan that is really going to describe what Connecticut's vision is for the future of its rail service. And this is a type of plan that other states, whether it's Rhode Island, Massachusetts, Maine, New Hampshire, every state is required by the Federal Railroad Administration to have one of these plans. And the reason these plans are so important is not only does it articulate that vision for what freight and passenger rail in a region should be or describe what the existing conditions are, but they really serve as opportunities for different stakeholders, whether it's your end users, your businesses, your elected officials, or even different members within a given transportation network, a chance to describe what's going on and what could be done to improve their results. And similarly, while these plans are helpful in understanding what the vision and future might be, they also help states achieve funding for these different projects. The FRA does not necessarily require a project to be in a state rail plan for it to be funded, but applications that say we are in a state rail plan are preferred and oftentimes are more competitive. In terms of the Connecticut State Rail Plan, there are some great time-saving benefits amongst others that will be achieved once the plan is fully implemented. This includes 25 minutes of travel time savings between New Haven and Grand Central Terminal. This is also referred to as time for CT, and it's going to end up saving commuters roughly 82 hours a year as a result of a series of infrastructure investments. Similarly, it's also going to lead to some service improvements for other parts of the state, whether you're a Hartford line user traveling up the middle of the state or someone using one of the branch lines in Connecticut, you're going to see some serious benefits as a result of the information in this plan. And when we think about this plan from a user perspective specifically, there'll be benefits like improved Wi-Fi or 100% accessible stadiums throughout the network, things that will really improve connectivity both for people traveling around now and for those who maybe want to travel but haven't been able to do so to date. This all will wrap up into some environmental benefits for the state of Connecticut, including a roughly estimated 900,000 reduction in daily weekday VMT, which means some serious environmental benefits from an emissions perspective. Understanding what goes into these plans and what can be funded as a result of them, I'm going to highlight a couple of the different grant applications that AECOM's been working on over the recent years. Some of these include applications for MassDOT and RIDOT, as well as applications for semi-private and private railroads like Amtrak, GNW, which owns St. Lawrence and Atlantic, and the Housatonic Railroad Company. What really makes the St. Lawrence and Atlantic Railroad Grant Award so special is the benefit it brings to freight movement both within New England and elsewhere. This recently awarded grant is going to allow the railroad to operate at 286,000-pound industry standard freight movements, which may sound like not a big deal, but it's going to allow freight in northern New England an opportunity to travel to points west like Indiana, Texas, Ohio, California. Many New England railroads aren't 286 compliant right now, which means they can't move the goods that are moving elsewhere. And this is going to update the network and really bring New England into the modern freight era. Another great grant award that was recently awarded is the Amtrak Boston and Albany line. This will allow Amtrak to run additional Lakeshore Limited trains at higher speeds. And many people attending this presentation may think of the Lakeshore Limited as a long distance train that runs infrequently, but what this will effectively do is allow MassDOT to have a compass rail or east-west rail sort of system, which can then be enhanced based on future investments earlier. Finally, I'm going to talk about some of the Connecticut grants. CT DOT is also presenting today, and they'll provide more specific information. But at the high level, the state of Connecticut has applied for many, many grants, roughly over $1 billion, and many of these grants were recently awarded, meaning there's going to be bridge improvements, track improvements, station upgrades, signal changes, you name it. Connecticut has won some money that's going to allow it to really modernize its railroad. And in a second, Andre is going to talk about two specific projects that were recently funded by this program.
Yeah, thanks a lot, Patrick. So a project is fortunate enough to win a grant. What happens next? First is the design phase. I'll be talking about two different projects that recently won grants and are now in the design phase, and then I'll also talk about a couple in the construction phase after that. So the first one is the Devon Bridge Interim Repairs Project. The Devon Bridge carries 4 tracks of Metro-North Railroad over the Housatonic River between Milford and Stratford, Connecticut. It's a 7-span structure, about 1,100 feet long, and twin structure as well. So the purpose of this project is really to extend the service life of the bridge an additional 10 to 15 years until the bridge can ultimately be replaced under another project, which is the second project I'll be talking about. So what are we doing under this interim repair project? The first thing we're doing is installing a structural monitoring system. The photo you see on the right was taken late last year of a bucket boat installing a sensor on the top cord of the truss. Here's another photo. You can see several different sensors attached to the bottom cord of a truss and the I-bar. Those sensors are connected to a data acquisition unit. The data acquisition unit then communicates with a gateway, which you see here in this cabinet. This is housed up on the operator's tower. The gateway then communicates up to the cloud where you can get your results in post-process. So a live load test was performed earlier this February on a cold Friday night. Here you see a GP35 locomotive running over track 2. There were several runs over track 2 and over track 4. And the really cool thing about this is you could see real time what those loading impacts or loading effects have on the individual members. Here you can see on the computer screen, and this all feeds up into a cloud service that can be post-processed later. At the same time, we've been developing this 3D finite element model of the bridge. So this really represents the as-built condition. What we'll do next is calibrate it based on the results of that live load test. And when I say calibrate, I mean we're going to run an identical loading over the bridge in the computer model. We'll see how that loading distributes through the structure to the individual members. And then we could tweak the model either through boundary conditions or stiffness modifiers so that the model closely mimics the behavior of the real structure. And from there, we can determine exactly which members need to be strengthened or rehabbed to achieve this 10 to 15 year service life extension. So the next project is the Devon Bridge replacement. We've completed the conceptual engineering phase in 2019, and in that phase, we looked at several different alternatives to replace the approach structures and the center movable structure. Here, I'll cycle through just a couple images from that report that we developed. Here's an option of the movable span. This is a rolling bascule. We also looked at a vertical lift main span. Here's a section of one of the fixed approach span alternatives. This is an open deck girder option. And here's just a general plan of what the proposed bridge could look like. So now as we move into the NEPA phase and the preliminary design phase, ultimately what we want to do is take those range of alternatives and narrow them down into a preferred alternative. And so this figure on the right, I know it's too small to read, but I'll explain what it's all about. So one of the first things we need to do is identify the environmental impacts of this project and of the construction. And when I say the impacts, I'm talking about any wetland or watercourse impacts, any endangered species impacts, impacts to the navigable channel, any noise and vibration impacts from demolition activities or drilled shaft installation, for example, any social impacts, railroad operation impacts, property impacts, or even hazardous materials impacts. Um, so how do we determine what those impacts will be? We need to sort of lay out what the construction sequencing might look like, or what the constructability looks like, which includes, new access roads to be able to, for construction equipment to access the bridge, or installation of trestle in the river, or are you floating pieces down on a barge? Are you storing that barge somewhere? Um, do you need laydown areas for contractor materials or equipment staging? Are you dredging the river at all to create additional depth? Um, so all of these things will play into ultimately this decision to narrow this range of alternatives down to a single alternative, which will then get progressed through the rest of the design phase. Now we'll shift gears a little bit to the construction phase. So this is a bridge, the Walk Bridge. Walk is short for Norwalk Bridge. It carries the Walk Bridge over the Norwalk River in Norwalk, Connecticut. The existing bridge is built in 1896, so over 125 years old. It also carries 4 tracks of Metro North, just like Devon Bridge. The existing bridge is a swing bridge, and it will be replaced with a dual vertical lift structure. So the photo you see on the top is the existing structure, and on the bottom is a rendering of the proposed structure. Construction has already started last spring. It will be complete in 2029. This project is utilizing what's known as a CMGC construction method, so construction manager, general contractor. And in this method, the contractor actually jumps on board the team early in the design phase to help make suggestions and recommendations about how to build the bridge quicker or more economical. The owner and operator, or the owner is Connecticut DOT and the operator is Metro North. Designer of record is HNTB. Contractor is a joint venture between Chimbro and Middlesex. The program manager is WSP, and AECOM is serving as the CE&I firm. And lastly, the Connecticut River Bridge replacement. Another major rail structure. This one is over the Connecticut River between Old Saybrook and Old Lyme, Connecticut. This one is another 100-year-plus old bridge. This carries 2 tracks of Amtrak. The existing bridge will shift the alignment of the rail about 50 feet to the south. So the tracks will remain live. The existing tracks will remain live while the new bridge is being built. Construction is expected to start in July of 24, complete by January of 31. This is a more conventional design bid build construction methodology. The owner and operator is Amtrak. Designer of record is Hardesty and Hanover. The contractor has not yet been determined, and construction management is being performed by AECOM. So with that said, thank you very much all for your time today. This concludes our presentation. Thank you.